Good morning, student, and welcome to our Zoom class session. In this class, I want to go through all the materials that I've posted with regard to correlation, so that now I can be able to move to the next part, which is on the regression. So the correlation, we said, is actually the measure of interrelationship between two variables. And we said in that case, we are going to have two variables, where the first variable, which is known as the independent variable, is normally denoted by x, and the other variable, which is known as the dependent variable, is denoted by y. So in this case, we have the x, which is representing the independent. It is the independent variable, and we have got the y, which is the dependent, variable. So we are trying to measure what is the effect of changing the x on the y. And we said in that case, the correlation can either be positive or negative. That is what we said. And we said a positive correlation arises where increase in x results to increase in y. And a negative correlation is where you increase x, y decreases. So you need to note the difference between the two. The positive correlation is where increase in x results to increase in y, and decrease in x results to decrease in y. That is positive. When it is negative, it is a case whereby you increase the x, the y decreases. You decrease the x, the y increases. So that is basically the difference between the two types of correlation. And then I also noted that in correlation, you can determine it using three aspects. You can have what we call the scatter diagram. You can measure correlation using the product moment correlation coefficient. And we have the third one, which is known as the rank correlation coefficient. So we have got those three approaches that we can be able to measure the correlation. We have the scatter diagram, the product moment correlation coefficient, which is also known as the Pearson's. It is also known as the Pearson's correlation. The Pearson's correlation, or the product moment correlation coefficient. Those are the three ways we can be able to measure the correlation. When it comes to the scatter diagram, we said it is where we have a pictorial. It is where we have a pictorial representation of actually the x and y variables. So it is a case whereby you have a graph. A graph will always have the x coordinate and the y coordinates. Remember, the x is the independent. So you can have a table whereby you have the x values and the y values, and they are given as maybe 2, 3, 8, 10. And here you are given the y values that corresponding to each x as maybe 5. This one is maybe 7. This one is 15, and this one is maybe 28. If that is the case, then you need to come here on the x-axis, you plot the x, or you put the x values. So it can be a case of 2, 3, 4, 5, 6, 7, 8, 9. You proceed up to where we have 10. And then on the y, you can have maybe 5. You have 10, you have 15, 20, 25, and maybe you have somewhere that so that we can be able to accommodate this value up to 28. So for the scatter diagram, you just go and plot where you have 2 and 5, you mark there. Where we have 3 and 7, you just go ahead and mark it. Where we have 8 and 15, just locate where you have 8 and you go up to where we have 15, then you mark it. Where you have 10 and 28, where we have X is 10 here and Y is 28. So you just look for 10 and 28, you mark it. What comes out is what we call a scatter diagram. So a scatter diagram is simply a diagram that shows the X values and their corresponding Y values without drawing a line. You just draw them and you don't indicate a line. And therefore, what comes out is known as the scatter diagram. And we talked about the different scatter diagrams that you can have. One, a line is going to be positively sloping. A line is going to be positively sloping. If you have any line that is drawn or it is behaving like that, it is sloping from the bottom left to the top right. That line is actually having a positive slope. If you have a line that is sloping like this, that line is having a negative slope. So when it comes to correlation, I want to go back a bit and maybe talk about the types of correlation so that we can move to the scatter diagram. That correlation, we said it can either be positive or negative. So a positive correlation is where the X values, which is actually the independent, and the Y value, which is actually the dependent, they move in the same direction. What do I mean by moving in the same direction? You can have a case like this. You can have a case like this. If, for example, we are talking about maybe fertilizer that you apply in your farm and production. So fertilizer here, the fertilizer will be your independent, and then the production will be your dependent, because the fertilizer here is actually driving the production. The more fertilizer you put, maybe the more the production will be. Therefore, a positive correlation will arise where if you increase X value, the Y value also increases. Like an example can be here, you have the fertilizer, which is given maybe in kgs, and production, and the production, which is maybe in sacks, number of sacks that you produce. If you can have a table like this, where maybe you apply 10 kgs of fertilizer, you produce maybe 20 sacks. When you add this one to be 15, just a minute. When you add the fertilizer to 15, just a minute, let me mute you people. So when you increase the fertilizer from 10 to 15, maybe your production increases to 25 sacks. When you increase this one maybe to 20 kgs, you apply 20 kgs of fertilizer, this one maybe goes to 30 sacks. You increase this one to maybe 26, this one goes to maybe 37, like that. This is a case of positive correlation, because as you are increasing the fertilizer here, the production is also increasing. That is a very perfect scenario of a positive correlation. If you reduce this, as you reduce this quantity from 26 to 20, this one also decreases from 37 to 30. You decrease this one from 20 kgs to 15 kgs, this one decreases from 36 to 25 kg. So this kind of a correlation is known as positive correlation. Increase in this increases the other. Decrease in this one is also decreasing. That is a positive correlation. A negative correlation will arise when the two variables are not moving in the same direction. Like, for example, you can have a case of price of a commodity, which is given in shillings, and maybe the quantity demanded the quantity demanded, and this one can be in kgs. So if you have a case like this, the price, when the price is maybe 15 shillings, consumers are willing to buy maybe 120 kgs. When the price goes up maybe to 20 shillings for that particular item, the consumers are only willing to buy maybe 105 kgs. When this one goes up maybe to 30 shillings, they are able to buy maybe 83 kgs. So you realize as the price is increasing, the quantity that the consumers are demanding is decreasing. Therefore, this one is a negative kind of correlation. You increase this one decreases. You decrease this one increases. That is a negative correlation. So when you proceed to the scatter diagram, how can you know whether it is a positive correlation and actually the level of correlation? You will find that if you have your points, upon plotting, they are behaving like this. They are all forming like a straight line, and the line is actually positive sloping. Remember, we said any line that is slopes like this, it is positive. This kind of a correlation, we normally call it a perfect positive correlation. This is a perfect positive correlation. When you have your graph behaving like this, you plot the x. Remember, on this side, you have the x values, and on this side, we also have the x, and here we have the y and the y. And note here, let me take you back a bit. Note here, the values of this particular variable, maybe in this case, it is fertilizer, these are the x values, and the value of the production, these are the y values. The same case, this one will be our x value, this one is going to be our y values. So when you come here, when we are talking about the x, so you just put the values of x as given in the question, you also put the values of y, then you locate the points and then you plot it like that. And the same case applies here for the y. So if they form a straight line, but that line is sloping like that, that is a perfect positive correlation. When the line is sloping like this, and the points are on a straight line, that is a perfect negative correlation. This is perfect negative correlation. You can have your points being plotted whereby the points are sloping actually like that. They are not forming a straight line, but that line is almost straight. That line is almost straight, but it is not straight. You have your x and you have here your y. This is known as a high positive correlation. A high positive correlation. They are almost forming a straight line, but it is not a straight line. It is a high positive correlation. When you have your points behaving like this, almost forming a straight line, but it is not a straight line, but sloping negatively, this is known as a high negative correlation. You can have another scenario like this. You have your x and y. The points are sloping like that. They are giving us a trend that is like that. You can be able to see they are actually having a positive trend, but these values are far from giving us a straight line. This is actually known as a low positive. They are not close to making a straight line. But if they behave like this, very far from making a straight line, but they are actually giving us a negative slope. We can be able to see that they are sloping like this. This is known as a low negative correlation. Then you can have a scenario whereby the points upon plotting the x versus the y, you find maybe your points are behaving like this. You cannot be able to tell whether they are sloping positively or sloping negatively. So if you find this kind of a scenario, this simply means that there is no correlation. This simply means that there is no correlation at all. So you need to note that correlation can either be perfect positive or perfect negative. When they are actually forming a straight line, then they can be high positive or high negative. When they are almost forming a straight line, there is low positive and low negative. When there is actually they are far from forming a straight line, No correlation simply means that those lines is like they form, or the points form like a circle or a square. You cannot tell whether these points are sloping like that or sloping like this. But the key point here is this: note the direction of the points. If the points, they tend to slope like this, just know it is a positive correlation. If the points, they tend to slope like this, that is a negative correlation. So it is upon you now to identify whether it is perfect, high, or low kind of correlation. Then upon saying that, we can go to the correlation coefficient. The correlation coefficient. The correlation coefficient, it is normally denoted by small r. So in this case, the small r, it is calculated. It is not like the scatter diagram where you plot and then you look on the way the points are behaving. The r is calculated using the formula n summation of xy minus summation of x summation of y over, you put here a very big square root where you have n summation of x squared minus summation of x. Here it must be into bracket squared. Then you multiply by n summation of y squared minus summation of y, everything into bracket squared. So that is how you get the value of r. But remember, the value of r can have a highest of +1 and a lowest of -1. That is actually your value of r. You cannot get an answer that is outside this range. Either it is going to be highest +1, where +1, it simply means it is perfect positive correlation. -1 simply means it is a perfect negative kind of a correlation. Then in between -1 and +1, we have got 0 correlation, which simply means no correlation here. 0 correlation means there is no correlation at all. And then here we have +0.5. Here we have -0.5. So this region between +0.5 and +1, this region, it is the region of high positive. If you calculate your value, find it is +0.6, 0.7, 0.8, 0.9, that is a high positive. If you calculate your R and you find that your R is coming from 0, that is 0.1, 0.2, 0.3, 0.4, that is known as the low positive correlation. If you calculate your value and you find it is between 0 and -5, that is -0.1, -0.2, all the way up to -0.4 point something. This is known as a low negative correlation, whereas this region is the region of high negative correlation. So we can have maybe an example of this so that I can demonstrate that formula. You can be given the values as follows. Maybe you are given the value to do with advertisement. This is our X value. And then we are given maybe the demand, which will be our Y value. It is simply going to give us the advertisement cost, the cost of advertising and the demand. If we advertise maybe using, let us say maybe this one is in 1,000, and the demand is also in 1,000 kgs. This one is shillings in 1,000 and this. So if we demand maybe using we advertise using 2,000, the demand becomes maybe 4,000 are going to be bought. If we advertise using 3, the demand goes to 5. If we advertise using maybe 5,000, this one goes to 7. And if you advertise maybe using 8, this one goes to 9,000 kg. Remember, we are advertising using 2,000 kg, and then the quantity that we can sell is 4,000 kg after advertising with 2,000. After using 3,000 as the advertisement cost, you find that now what we can be able to sell is 5,000. Just a minute, let me mute somebody here. If, for example, you advertise using 5,000, you are able maybe to sell 7,000 kg. So you can be able to see the more you advertise, the more you are going to sell. Then you are told you calculate. The question here is calculate Pearson. This is Pearson correlation coefficient. You are told you calculate that. So what you need to know is that you are told to calculate the value of R, which we have said is given by n summation of xy minus summation of x summation of y over, you must remember to put this big square root of n summation of x squared minus summation of x into bracket squared minus, so not minus, but multiplication here, times n summation of y squared minus summation of y into bracket squared. What you need to come and do here in this question is simple. Just get the column. Remember here we need the sum of xy. So you need to come here and put xy. You get that. We also need, already we have the x. So if we add all the x's, it's going to give us the sum of x. And if we add all the y, it's going to give us the sum of y. So this part is sorted. Then we need a column for x squared and another column for y squared. Then the question can be done. Remember, anytime you find this sign being used, this sign simply talks about the sum. The sum, and the sum here we mean you add. So here when we are talking about the sum of x, it is simply you add all the x values down. When it is the sum of y, it simply means we add all the y's down the table. So when it's talking about the summation of xy, then we need to get the xy. Xy in this case, it means x value times the corresponding y value. Like in this case, we are going to have 2 times 4, which is actually 8, 3 times 5, which is actually 15, 5 times 7, which is that 5, and 8 times 9, which is what? Leslie, let me confirm whether we have students in class. Leslie, what is 8 times 9?
72.
Exactly, thank you. So we have this one is 72. Then we need to get a column for x squared. X squared simply talks about all the values of x that we have, we square them. So we are going to have 4, 3 squared is 9, 5 squared is 25, 8 squared is 64. The y squared here simply means we square the y's. So the y here, somebody is not muted. Okay. I was talking about the y squared. Y squared simply means we square all the y's. So we are going to have 16, 25, 7 squared is 49. Then we have 9 squared, which is 81. Then now we can get the summations. We can get the summations. So here, when we talk about the summation of x, we just add all the x's, you get there. You get the summation of y by adding all the y's. You get the summation of xy, you add all the xy's. The summation of x squared, you just add all the x squared. The summation of y squared, you add all the y squared. So if we start here, I need your assistance here. This is 5 plus 5 is 10. This one gives us 18. This one is 9 plus 7, that is 16. 16 plus 9 is actually 25. This one I will ask you maybe to assist me in multiplying or adding, sorry. Let me add, it is 8 plus 15 plus 35 plus 72. If you add, you get it is going to give you 130. If you add the x squared here, it is going to be 4 plus 9 plus 25 plus 64. You get it is going to give you 102. Then the y squared is 16 plus 25 plus 49 plus 81, 171, like that. So we can come and apply our formula. We can come and apply our formula where we need to get n summation of xy. The value of n is simply the number of x that we have here or y. The number of rows we have, we had 1, 2, 3, 4. We had 4 pairs of x and y. That is what we were given by the question. Therefore, our n is 4, like that. So our r will be given by 4, which is the value of n, times the summation of xy, which is 130, minus the summation of x times the summation of y. The summation of x is 18 times the summation of y, which is 25, over n, which is actually 4, but don't forget to put the square root here. Don't forget to put the square root there. It is n summation of x squared. Summation of x squared is 102. So it is times 102 minus the summation of x into bracket squared. The summation of x into bracket squared is the same as 18 into bracket. The summation of x into bracket squared is the same as 18 into bracket squared. So we come here, we put 18 into bracket squared, then we minus n, which is 4, times the summation of y squared. The summation of y squared is 171 minus the summation of y into bracket squared. It is the summation of y, which we have it as a 25. We have it as a 25, then we put into bracket squared. So you are going to find your answer being 4 times 130. This is 4 times 130, which is coming to 520, minus 18 times 25. 18 times 25, which is 450, over 4 times 102. 4 times 102, which is 408. Don't forget the square root. So we have it as 408, this part, minus 18 squared. 18 squared, the same as 18 times 18, which gives you 324, minus this part here, which is 4 times 171. 4 times 171, which is giving you 684, minus 25 squared, which is 625. Then you continue evaluating it like that. So 520 minus 450, 520 minus 450, which is actually 70, over the square root 108, 408, sorry, minus 324. 408 minus 324, which is actually 84. Here it is actually supposed to be multiplication. We forgot it is supposed to be multiplication, not minus. It's supposed to be times. And here also, sorry for that, it is supposed to be multiplication. It is supposed to be multiplication here, or down, it's supposed to be like that. So this one, we have found it to be 84. Then 684, so we put here times 684 times minus 625. 684 minus 625. 684 minus 625, which is actually 59. So you will find this one is going to give you 70 over the square root of what? 84 times 59 times 50 times 59, which is 4956. 4956. So you evaluate this. Actually, let me find out the square root of is giving us actually 70. So it's going to be 70 over, let me find my answer, 70.39, which is the same as 70.40 to the nearest 2 decimal. So if you divide this, 70 divided by 70 point is giving you 0.9 something. Let me confirm, 0.994. 0.994. So that is actually now your R, which is the correlation coefficient. That is how you calculate. And then in most questions, when you are given this question, maybe in a NEC paper, you will be told you calculate the correlation, the Pearson or the product moment correlation coefficient, and then part B or part 2 will always to interpret the answer. You are told you interpret this answer. So when you are told to interpret the answer, you are simply supposed to come to this particular point and you identify where is your answer lying, in which region. You will find positive 0.994, it is lying in this region between positive 0.5 and positive 1. So it is a high positive correlation. So this answer can be interpreted as there is a high positive correlation between advertisement cost and the demand of that particular product. So that is actually on the Pearson correlation coefficient. And having noted that, we can go to the last category of correlation where it is supposed to be the rank correlation coefficient. The rank correlation coefficient. And when we are talking about the rank correlation coefficient, it is when these two variables are actually ranked. When we talk about ranked, we simply mean from number 1 to number last. You can find a case whereby students, or let me talk about candidates in an interview. They go in an interview, maybe there is a panel of 2 people who are interviewing them. As they are being interviewed, the panelist number 1 is giving the score for each candidate, and the panelist number 2 is also giving the score for each candidate separately without actually comparing. You are interviewed, asked the way you respond to the question, you are ranked by each. Then we might be interested to know what is the correlation between the ranking of panelist 1 and the ranking of panelist 2. In short, where panelist 1 was giving high scores, if panelist 1 gave high score to candidate A, what about now the ranking or the marks of panelist 2 on the same candidate, so that we can be able to find out whether the marks awarded by the first panelist, they are actually correlating with the marks awarded by the second panelist, or they are giving the same score. If candidate A scored high marks in panelist 1, did he or did she score high marks when it is a panelist B? We can also have a case of maybe the beauty contest, whereby you have judges. We have judge A and judge B. Then participant number 1 or competitor number 1, I will ask you to mute your mics. Competitor number 1 is maybe appears on the stage, and then Judge A will give the score, and then Judge B will also give the score to the same competitor. We might be interested to know where Judge A gave high marks, does Judge B also give high marks? Where Judge A gave low marks, does Judge B gave low marks? Do we have correlation? If we find that where A gave high marks, B also gave high marks, then there is a high correlation. But if we find where A gave high marks, B gave very low marks, then there's a negative kind of correlation. But the key thing, first of all, you need to understand there must be ranking. So you can have an example where you are told the competitors, they competed in a particular beauty contest. And then we have like this, the competitor was maybe A, B, C, D, and E. We had 5 competitors. And then we had 2 judges. Let me clean this part. We had 2 judges whereby we have just a minute. We had 2 judges. I don't know where my cursor is disappearing to. The board is misbehaving. We had a competitor A, B, C, D, and E. Then we had marks awarded by Judge A, or Judge, let me use Judge 1, and we also have the marks awarded by Judge 2, like that, or the ranking. Let me call, this is the ranking. Ranking according to Judge 1 and ranking according to Judge 2. So according to Judge 1, competitor C was number 1, but D maybe was number 4. This one was number 5. This one was 3, and this one was 2. So in this case, you must know who was, they must rank in a scenario whereby there is number 1 all the way to number last. So according to Judge 1, this is how they performed. Competitor C was number 1, this was number 2, this was number 3, number 4, and number 5. But according to Judge number 2, this one was maybe number 1, this was number 2, this one was number 4, maybe this one was number 3, and this one was number 5, according to Judge B or Judge 2. Then you are told, can you calculate the rank correlation coefficient? If you are told to calculate that, you should be able to know the rank correlation coefficient is normally denoted by capital R, is calculated using the formula 1 minus 6 summation of D squared over N into N squared minus 1, where N is the number of maybe competitors. In this case, we had the 5 competitors. So in this case, our N should be 5 competitors because they were 5. So you will find now what you need to do is to get the value of D squared. And how do you get the D squared? It is as simple as this. You need to get the column for D, and then that column of that value of D we square so that we can have the D squared. D is simply the difference between the ranking of the first person and the ranking of the second person. In this case, it's going to be 3 minus 2, which is 1. This is 2 minus 1, which is also 1. 1 minus 3, which is a negative 2. We have 4 minus 4, which is 0. 5 minus 5, which is 0. So we square the values of D that we have obtained. In this case, it's 1 squared is 1. 1 squared is 1. Negative 2 squared is positive 4. This is 0, and this is 0. So we need to add the d squared so that we can get the summation of d squared. In this case, it is 2 plus 4, which is 6. So our r in this case would be 1 minus 6 times the summation of d squared. The summation of d squared is also 6 over n is 5 into bracket 5 squared minus 1. Therefore, it's going to be given by 1 minus 36 over 5 into 25 minus 1. That is 5 squared is 25 minus 1, which will be equal to 1 minus 36 over 5 times 24. 5 times 24, which is going to be actually 1 minus 36 over 5 times 24, which is 120. So we are going to have it as 1 minus 36. 36 divided by 120, which is 0.3. So you'll find the answer is going to be 0.7. That is 1 minus 0.3 is 0.7. 0.7, and actually remember here it is positive. So it is a case of a high positive correlation also. So basically that is how we do it. Basically that is how you do it. The rank correlation, you need to have the ranks. We can have another example. In some questions, you cannot be given the ranks, but you are supposed to rank it. You can be told we have maybe the competitor. Somebody has raised a hand here. Asin, there's somebody.
I have a question.
Yes, please ask.
Yeah.
Asin.
The D, how did you get B?
Hey, I am getting you. Can you kindly maybe reduce the volume of your radio? I think you are somewhere close to a radio or a gadget as I answer your question.
Okay, just a minute.
Okay.
Yeah.
Okay, let me go back there. Let me go back. The D, the D, it is the difference between the ranking. Like for example, Judge 1, the competitor A, according to Judge 1, he was number 3, and according to Judge 2, he was number 2. So what you need to do here is to get the difference. In this case, it is 3 minus 2. That is where we get 1. This is 2 minus 1, which is 1. 1 minus 3 is negative 2. 4 minus 4 is 0. 5 minus 5 is 0. It is the difference between the two rankings of the two judges. As in, is it clear? As in?
Yeah, it's clear.
Okay, that is how we get it.
Yeah, thank you.
Karibu. I was explaining this point here where we have maybe the competitors A, B, C, D, and E. You can find some questions, they don't give you the ranking. You find maybe a question is giving you this. It is giving you the marks they scored. The two judges, they were giving marks. That is actually Judge 1 and Judge 2. They gave the marks instead of the ranking. Remember, the ranking is the position. So in this case, Judge 1 gave a competitor number 1, maybe he gave it 40%. This one was given 60%. This one was given maybe 84. This one was given maybe 55. And this one was given maybe, we can call it about maybe 74%. According to Judge 2, this one was given, let me start with this. This one was given 52. This one was given maybe 50. This one was maybe given 69. This one was given maybe 75. And this one was given maybe 65, like that. instead of giving the ranking, they gave the marks. If you come across this kind of a question, then you need to be a bit creative. You cannot work with these figures the way they are. What you need to do, you come up with the ranking. You have the ranking 1 and the ranking 2. Ranking 1 is as per the judge 1. As per the judge 1, this competitor, who was number 1, you can be able to come here and you find out who scored the highest marks, which is C. So according to judge 1, C was number 1 because he had the highest marks. This one was number 2 because he was the second. Number 3 will be this one because he was the third highest. This one was number 4, and this one was number 5. According to judge 2, number 1 was actually this person. Number 2 was this. Number 3 was this. I'm just going per the marks. Number 4 is this one who had 50. And sorry, number 4 will be this one. This person would be number 5. Number 5, like that. That is the ranking. Now, you can be able to get your D and then your D squared. So you'll find that your D, you minus the ranking, which is 5 minus 4, which is 1. This one will give you -2. This one will give you -1. This is 4 minus 1 is 3. 2 minus this one is -1. So your D squared will be 1, 4, 1, 9, and 1. You square the values of D. So you can get the summation of D squared being equal to, this is 5, 6, 15, 16. Now you can go ahead and get the value of R, which is given 1 minus 6, summation of D squared, which is 16 over N. N, they were 5 into 5 squared minus 1. You can proceed like that. But the key point I want you to understand, when the values have not been ranked, you rank them first. You rank them first, and then you get your D and D squared. I want to end the class at that point. Anybody with a question? Leslie, are you okay? Anybody with a question? Anybody with a question somewhere? If you have a question, just feel free to ask. Okay, everybody seems to be comfortable. So I can comfortably say that I have covered the first part on correlation, and from tomorrow, I will now go to the regression part of it. So you can only be asked about those questions or the ones that I've highlighted. In most cases, you will be told to calculate the correlation coefficient, which is small r, using the very big formula, or the rank correlation coefficient using the formula that we have just covered. But take note, we have the materials that I've shared, which are actually very comprehensive. You can be able to do that. As we move ahead, I will be sharing maybe the past papers so that you can be trying on your own. And when we meet in this Zoom platform, you can be able to raise any question that you have as far as your revision is concerned. So we have gone actually online, so don't be left behind. I know some of you are wondering how things like a QT can be handled online. This is how we are going to handle it. It is actually a very good experience. Just come on board. We finish this thing once for all. You are left to do your revision as you wait for your next exams. Otherwise, I don't have much to say. I will beg to end the class at that point, and I wish you the blessed moment. So we are going to have our Zoom classes twice in a week. I know we have got 4 lessons. We have got 4 lessons. The 4 lessons that we have, 2, I'm going to make sure that I give you the materials plus the videos, and then in the Zoom classes, we are going to look at now the notes that I shared. I give it now an explanation in a one-to-one scenario like for today, and then in this Zoom, we are also going to share the questions that you have as far as your revision is concerned. I want to maybe say this. Today is on Tuesday. The next class is on when? We have Monday, Tuesday.
Thursday and Friday.
Thursday and Friday. Okay. The next class will actually come on Friday. On Friday class, the class for Friday is going to be via Zoom. But for Thursday, I'm going actually to share the materials so that now you can be able to be prepared for that Zoom class. So Friday, it's a Zoom. Let us be having it Tuesday and Friday. Always, they are Zoom classes, unless we communicate otherwise. I want to end there. Let me wish you a blessed day.